Hello everyone, hope you're doing and welcome back to my channel. Today we are at day 18 of the January daily LeetCode challenge, and finally we have a hard question. From the last 2 days, I guess from the last 4 days, we were having questions on the topic of bit manipulation. We have seen some very good questions, and if you have not checked that out, please go and see my video. I have like explained in a path. Okay, if you follow that path, I'm damn sure that you will find the topic helpful. You can see, go through the comments in my previous videos. Many of them have felt the same, that yeah, they were able to get the proper grip of the topic after going through the same path. Okay, after going through the same level of difficulty. So please go through them, check out those videos if you have not seen them previously. So there was something which is really good. Bit manipulation is a topic which will be difficult for many. Okay, many won't be able to do it because it needs a lot of imagination. It needs a lot of hands-on practice. Okay, if you have not learned the basics of bit manipulation, remember you won't be able to do it. That is where difference comes between a CS student and a non-CS student. Okay, CS means the computer science. So those are not from the CS background; they are from mechanical or electrical backgrounds. They find these topics a bit difficult because they have not studied the basics of like how these things are being done. Okay, how internally, like how the compiler, or let us say not the compiler, but yeah, how the computer itself is doing the additions, how the bits are helping us do the calculations or multiplications, division, all those stuff, right? Those things, if you know, bit function will be very easy for you to think of and imagine. Okay, as simple as that. That's the only thing that I want to tell you. So if you're not from CS background, please do be try to be very good in bit manipulation, because that will be something where you will be lagging compared to a CS student. Now coming to this question, it is going to be a not something related to bit manipulation. Let me be very frank, this is a different question. I guess we are now going to start with again the topic of the DP or the graph. This question can be solved using both DP as well as graph. I am showing you multiple approaches of graph today. Okay, we will be seeing BFS, we will be seeing different version of BFS. At the same time, I will also be showing you the Dijkstra's algorithm. Okay, which according to me is working the best in my case. I will show both of them. Okay, I will show two variants of BFS, and then we will see one variant of Dijkstra's algorithm. When I say BFS, do not think the original BFS. Always there will be some modifications in each of our solutions. Okay, so in the current BFS also, I am not using Q. I will be using a DQ, and I will show you how it works. Okay, I will also tell you why I am using this. Okay, so these solutions are very different. This is based on my analysis. My analysis tells me that these solutions are working good, but yeah, the Dijkstra's is working the best. Okay, so I will be showing in the same order. So yeah, friends, let us quickly begin with this video. It is 1368 minimum cost to make at least one valid path in a grid. Okay, you can see the diagram first. See what we are given is, throughout the grid we'll be having four numbers in the grid. Okay, each cell of the grid is going to have four numbers, 1 2 3 and 4. Okay, so when the one is there, okay, it means that we can go towards the cell see, we can go to the right cell, okay, without incurring any cost. Similarly, when the number 2 is mentioned, it means that we can go to the cell towards the left without incurring any cost. Similarly, if the number is 3, we can go to the bottom cell. If the number is 4, we can go to the top cell without incurring any cost. See, I'm just explaining you in very easy words, I can say. Then we'll see the actual question. Okay, the actual was they mentioned. See the diagram. See diagram, we are going to start from 0 comma 0, and we should be ending at n minus 1 comma n minus 1. Okay, that is the right bottommost cell we are going to end, and we have to start from 0 comma 0, which is the left top cell. Okay, now our aim is to reach from 0 comma 0 to n minus 1 comma n minus 1. Okay, that is our aim. Now also we'll have to ensure that we occur the minimum cost. So when is the cost going to come? See this part. If you are following the diagram, that is, if you're following the arrows given, you are not going to incur any cost. But if you want to go to a, you are trying to take a path for which the arrow is not supporting you, in that case you will have to incur a cost. Okay, that for example, see here, if I follow this arrow, I'm reaching the last cell, but that is the last cell in the row number 1. But after that I cannot go anywhere. Okay, because there is no sign to go to the row below that. Okay, for that reason we will have to change the sign of one of the cells here in the row number 1. For that reason, if you are changing any of the signs, you are going to incur a cost. Okay, so that is the basic idea. So the question is about how to reach the right bottom of cell with a minimum cost. Okay, remember, this question has nothing to do with the shortest path. Okay, they are not asking you to take the shortest path. Okay, they have also mentioned that in the question. See this path, the valid path need not be shortest path. They are just saying it has to be a valid path, and you have to ensure that you are incurring the minimum possible cost. Okay, as simple as that. Yep. So that is the question, and we'll have to see how much cost we are going to occur. Okay. So let us see the question now in terms of their words. You are given a M cross and matrix, and one more thing. Let me show the constraints before I start, because that will see. I always emphasize on these things, because even in interview, get these questions. Always after seeing the question, after understanding the question, ask for the constraint. Okay. After verbal discussion, ask for the constraints first. Okay. And then if they are going to give you the question from a coding platform, then you can go and start reading the question. But always after a verbal explanation that they give, you should be asking the constraints, and only then you should be going inside the question. Okay, This will help you. This will give you some seconds to analyze, okay, what solution to apply. Okay, in this case, as you can see, the m and n are going to be within a range of 100. Okay, that is, it's at max it is going to be a 100 cross 100 matrix, and each of the cells value is going to be 1 to 4. Okay, why 1 to 4? We have already seen that here. Okay, 1 to 4, we will be explaining that part here. Okay, now see this part. Given m cross n grid, each cell of the grid has a sign pointing to the next cell you should visit if you are currently in this cell. Okay, so each cell you have a sign which tells you which is the next cell that you are going to visit. Okay, as simple as that. The sign of a grid can be one among them. So among 1 to 4, any of the signs can be there. Okay, so what are their meanings? It's mentioned here. One means toward I can go towards the right cell. Okay, two means I can go towards the left cell. Three means I can go towards the cell at the bottom. Similarly, I can go. Four means I can go to the cell just above the current cell. Okay, notice that there could be some signs on the cell of the grid that uses. Okay, so what they're trying to say is, if you follow the science, there could be a case that you can be going outside the grid. Okay, so that can also happen, but remember, if you're going outside the grid, you cannot proceed further with that. Okay, as simple as that. So finally, you will initially start at 0 comma 0. A valid path in the grid is a path that starts from the upper left cell, that is 0 comma 0, and ends at the bottom right cell, m minus 1 comma n minus 1. Okay, whichever way you call it. So in my solution, what happens, I will be calling it as n minus 1 comma m minus 1, because I have taken n and m like this. Okay, but in this case, it seems they have taken the reverse. That is, for them, m is going to be the number of rows and n is going to be the number of columns. So for them, it is like this, but yeah, for me, it will be n minus 1 comma m minus 1. Okay, as simple as that. Okay, following the science of the grid, the valid path, okay, does not have to be the shortest. Remember, this question is not at all about the shortest path. Okay, this gives you another hint that you need not worry too much about being the shortest path. You can also see, this gives you that you can even try the BFS. Okay, that is the first thing that I want you to capture. See, they are talking, it did not be the shortest path. Okay, it just has to be a valid path. And yeah, you will get to know that we also have to bother about minimum cost, but the idea here is you have to explore all such possible paths, and among them, whichever is the least one, you have to take that. Okay, so this also gives you a hint that we can go for BFS. Okay, because in BFS, if you see, it's just a traversal. Okay, it is not a shortest path algorithm. Please be very mindful of these things. Okay, in the interview, if they ask you what algorithm you are going to apply, if you are given a scenario where you have to find the shortest path, you should not say BFS. Okay, BFS is just a traversal algorithm. Okay, yeah, as simple as that. Like we have in trees, we have some in order traversal, and okay, all those orders are traversal, post order traversal on that. Okay, so DFS and BFS are also some called traversals. They are not algorithms to find the shortest path. Remember that part very, very keenly. Okay, if you want to see how much, like, what are the possibilities of traversal, then you can take BFS and DFS. This is one such question where you can try the BFS. Okay, because here they are not bothered about the shortest path, right? Next is that you can modify the sign of a cell with cost equal to 1. That is, if you're trying to modify the sign of cell, for example, see here, let us say I am at this particular cell. Okay, and I see this cell takes me out of the grid, but I don't want to do that. I want to go to the row below it. For that reason, I have to change the sign of the cell. Okay, that will make you incur a cost of 1. Okay, as simple as that. You can modify the sign of a cell only one time. That is, always remember, only once you can modify the sign of the cell. Okay, throughout one path, as simple as that. So return the minimum cost to make the grid have at least one valid path. Okay, so ultimate aim is to reach the right bottommost cell from 0 comma 0, such that we are following a path which incurs the minimum possible cost. Okay, so this is the question. Yep, so that is the question. Now let us see what we can do. So yeah, we have already seen the constraints. Please go through the question. I've given the link in the description. Go through that and let us see what we can do. So the first idea that comes to my mind is that, see this part very keenly, we will follow a BFS approach. Okay, what is BFS? BFS means, when I am at 0 comma 0, what are the possibilities? See, BFS is a layer by layer algorithm, right? We are going through each layer once, okay, each level once. It's a level wise algorithm. So similarly, what we can do here is, when I'm at 0 comma 0, I can explore all the possibilities. Okay, that is, if I follow the path of the the arrow, then the cost will be 0. If I don't follow the path of the arrow, then the cost that I will incur is 1. Okay, accordingly, we can design a BFS algorithm. So that is the first solution that I am going to try. See this part. So yeah, it did not meet the most optimal solution, but it's a good one to start with. Okay, because we have a hint here that, yeah, the valid path need not be the shortest. Okay, as simple as that. We are not bothered with the shortest path. We just want to explore all possible paths, and then we can decide which one is going to help us get the minimum possible cost. Okay, now see this path. So see, if you pay attention to the first solution very keenly, the rest of the solution will become very easier to you. Okay, so please pay attention here. See, I'm just capturing the, see, this is going to tell me how many rows are there. This is going to tell me how many columns are there, right? Then I'm going to create a cache. So what is this cache going to tell? This cache is going to tell me that when I enter a particular cell, okay, let us say x comma y. So to enter x comma y, what is the previously what is the minimum cost that I incurred in order to enter X comma Y. Okay, so that is what the cache will tell me. This initially is having float of infinite. So whenever we are seeing a smaller value, we'll be changing the value here, and then okay, see, I will tell you where this comes. Okay, when this comes, I will be telling you that. But the idea here is whenever, let's say I'm visiting the cell again, and this time the cost is higher compared to the what cost I entered in the cell previously, then I will not explore that part further. Okay, this will help me reduce some of the unnecessary traversals. Okay, so this, for that reason, this is important. And anyway, we have just 100 cross 100 matrix, so this need not be a major bulk. Okay, there need not be a major overhead. Okay, as simple as that, right? So we are maintaining a cache. The purpose of the cache will become more clear when you see the solution. Okay, simple as that. See, normally in BFS, what happens is, you create a, see, in case of graph, I'm saying, in case of graph, what you have to do is you have to create a visited set. Okay, you have to do something like that. But in this case, it is going to 100 cross 100 matrix. So for that reason, I am maintaining a cache. So instead of making a visited set or a hash map, I'm maintaining a array here, to the array, right? Similarly, since we are going to start from 0 comma 0 itself, so the value in the cache for 0 comma 0 is going to be 0. Okay, as simple as that. Remember, it's the cache value that we have to return at last. See this part. So yeah, it's always good to emphasize. Remember, the last case, I guess the 66th case, will fail if you're not doing this case. Okay, so let me tell you this very frankly. If you have not done this, then yeah, if you, even if you don't do this, your solutions will get passed. But yeah, there is a case, I think, yes, the last case, case number 66, that will fail if you have not done this, because the last case is having a single element. Okay, so that will fail if you have not done this, right? Now I'm going to start with a DQ. Why a DQ? So see this part now. uh, what you can do is, see, I am going to append at the right side, and I'm going to pop from the left. Okay, I'm going to pop from the left. So that is the idea that I'm going to try with. For that reason, I need a DQ. Remember, if you take a normal list here, what will happen is, see, why I'm taking a DQ, this point will become more clear when you see the next variant of it. Okay, when you see the next variant of the solution, why you have taken this point will become more clear to you. Since I had that idea in my mind, for the reason for this also I started with a DQ. Although for this solution you do not need a Q. Okay, you do not need a DQ, but the next variant that I'm going to show you, that will become more clear to why I'm using a DQ. Okay, so the advantage of DQ is that you can pop from left and right at the O of one time. Remember that, O of one time. But in normal list, what happens? You can pop from the right and O of one time, but if you try to pop from the left, it will lead to O of one time complexity. Okay, so with DQ you can pop. See, DQ means a double-sided queue, right? Double-sided queue means you can pop and append from both the sides in same O of constant time. Okay, as simple as that. That is the advantage of DQ, right? You can even take a queue in this particular case, right? And then I'm going to append this particular this whole thing what I'm showing you. This is called a tuple in Python. Okay, this whole thing, okay, is called a tuple. This is going to be my element number one. Okay, this is being inserted in my queue. Okay, so let me zoom in. So see, start to understand what is happening here. See, this is X, this is Y, and this is the cost incurred for X and Y, to reach X and Y. Okay, since I'm going to start itself from X and Y, so the cost incurred while reaching X and Y is going to be 0. So this is the interpretation of what each of the number means here. Okay, as simple as that. Next I'm keeping a direction cell. In the direction itself, I see this part. This is a direction cell, comma 1 comma 0, minus 1 comma 0, 0 comma 1, and 0 comma minus 1. Okay, one good thing that I've done is, see this part, instead of writing if conditions to handle this kind of cases, what I've done is I have interpreted the number here itself. For example, see this 1 comma 0 means you are going below. Okay, you are going to the cell below it. Okay, as simple as that. For that reason, if you see 3 means that. Okay, 3 means going to the cell below it. Okay, for that reason I've incurred this also here. So this will tell me whether I need to incur a cost or not from going from X comma Y to X plus 1 comma Y. Okay, so for that reason, this, so 3 basically means going to the cell bottom. Okay, to the lower cell. So this will be through 1 comma 0. Okay, so I've written 3 here itself. Okay, similarly for 4, if you see, 4 means going to the cell above it. Okay, 4 means going to the cell above it. Similarly, if you see 1 means going to the cell to the right of it. Okay, 1 means going to the cell to the right, and similarly 2 means going to the cell to the left. So same thing I've written here, going to the cell to the left means 2. Okay, this is what this 2 means. Okay, how I'm interpreting this you will get to know, okay, in some time. So just pay attention. Next, see, this direction is done. Next, see this part, till the queue is not empty, this while will be continuing running. I am popping from the left, point number one. See, currently, if you are implementing a basic BFS, you need not pop from left. You can pop from, you can do a simple pop, which will pop from the right. You can do that, but the variant that I'm going to show you in the next solution, that will make more sense when we are doing, why we are doing pop left. Okay, let us see for that. You can just wait for that. I had that in my mind, so for that reason, I started with itself with the DQ. But although for this solution, do not need a DQ, right? I expect that. Then yeah, so whenever we reach the target node, what we can do is, we, instead of exploring all its all the directions and all that, we need not do that. So whenever we reach the target node, just continue and let the while loop continue. Okay, as simple as that. Do not execute the rest of the code whenever we reach the last node. Okay, why this matters, again you will get to know when you see the rest of the code, right? See this part. What I'm doing is, I am now going for all the values in the direction. What is the direction? This is the direction array, right? So what I'm doing is, for the current node, see this part, x and y, x comma y is the current node, and this is the cost incurred to reach x comma y. Remember that, right? So what I'm doing now, I have to go to the next nodes. Okay, x comma y is the current node. I have to go to its neighboring nodes, right? So let us see this part. What are the possibilities for going its neighboring node? I comma j comma cell direction. Okay, so this is I comma j. Okay, I comma j is this, and cell direction is this. Okay, as simple as that. So I'm going through all the directions. That is all the four directions, right? Then I'm adding them to my x. Okay, x I will be added to x, j will be added to y. Okay, so I'm getting double x and double y. So double x and double y is going to be the next cell to which I'm going to visit. Okay, I'm just checking whether if x is not within the grid or y is not within the grid. Okay, I'm just checking that whether double x or double y, if any of them is not within the grid, okay, we cannot proceed further. Okay, so for that reason I will just continue in the for loop. Okay, if that is the case. So when I'm going to execute this part, this means, okay, if we are not, this condition is not true, that means x and y both are in the grid. Okay, as simple as that. Next, what I'm checking is, if grid of x comma y, that is, remember, current cell, that is the next cell that I'm visiting is double x double y, the current cell is x comma y. Okay, so I'm just checking whether grid of x comma y is equal to cell direction. From where cell direction is coming? Cell direction is coming from here. Okay, grid of x comma y, as you can see, is something like this. Okay, the value is from 1 to 4. So I'm just checking whether, in if the direction is also, see, for example, if I'm at 0 comma 0 and the cell direction is toward the right. Okay, so in order to move to the cell towards the right, I should not incur any cost. So I'm just checking that if this is the case, I will not incur any cost. Okay, this just I'm verifying that. Okay, if this is the case, I'm not going to incur any cost. Okay, as simple as that. So the idea here is I can move to the next cell without incurring any cost. So I'm just checking whether, now see, now I have, now I'm going to visit the x comma y. Okay, double x double y, right? See this part, I'm just checking whether the cache value for double x double y, okay, and the current cost with which I'm going to enter double x double y, if there is any difference between them. That is, let us say the cache value. See, initially all the cache value will be float of invariant. Okay, but let us say we have visited the cell once. Okay, so in that case, some value will be there here. So the idea here is we should not enter with a cost which is greater than the cache to cost. Okay, do you get with me? Okay, are you getting this point? So the idea here is, if we have already visited double x double y with a lower cost, we should not enter with a higher cost now again. Okay, as simple as that. So I'm just checking whether the cost till now, that is the cost with which I will be entering double x double y, if it is less than the cached value of this, then if we are fine, we can again enter. Okay, as simple as that. Otherwise we should not enter, right? So I'm just updating the cached value. So cache of double x double y is equal to cost till now. Okay, and then I'm going to append this value. Okay, what is this value going to tell me? This value is going to tell me that, again, like, we are now visiting double x double y with this particular cost. Okay, this cost and this cost are same because we are following this. Okay, because double x double y is following the direction given in grid of x comma y. Okay, for that reason, the cost incurred to reach double x double y will be same as the cost incurred to reach x and y. Okay, as simple as that, right? I hope you are getting this point. Now, if this is not the case, that is, if this is not the case, then we have to incur a cost in order to go from x comma y to double x double y. Okay, I hope you understand this point. So the idea is, if you are not following the arrows here, you'll have to incur that cost. Okay, they have mentioned this point here very cleanly. Okay, as simple as that. Now, for that reason, what I have to do, I'm just checking whether the cost till now plus one. Why this plus one is coming? Because we are not following the direction, so we'll have to pay incur a cost. Okay, as simple as that. If it is less than the cash value, okay, only if it is less than the cash value, only then I am going to visit that node again. If it is not the case, then I'm not going to visit that node again. Okay, the idea is very simple. If I already visited that node, I should not visit it again with a higher cost. Okay, as simple as that. Otherwise it will be like an endless loop, right? I hope you're getting this point, right? So cached, I'm just, if this is the case, what I have to do, update the cache value of double x double y. Okay, it should be now cost till now plus one, and then append the, okay, append this particular thing. Okay, in the queue, what is the value? Double x double y, that is the node I'm visiting, and the cost in this case will be cost till now plus one. So see the difference, it is going to be cost till now plus one here, and it is going to be cost till now here. Okay, that's the only difference because of this. Okay, if you are following the direction of the arrow here, then it is fine, you should not incur any extra cost. If you're not following the direction, in that case you have to incur a cost like this. Okay, so the idea here is, when I'm x comma y, I'm visiting all the cells in the all the four directions. That is, I'm going, I'm planning to go to all the four adjacent neighbors. Okay, in all the directions. Okay, all the four prominent directions. That is, right, left, top and bottom. Okay, so if we are not following the directions mentioned in the grid, we have to incur a cost. Otherwise we should not incur a cost. Okay, so this will keep continuing till we have element in the this particular queue. Okay, one more thing is that, see this part, because of this condition, what will happen is, we will not be exploring multiple cases. Okay, other here is, whenever we try to reach a particular, for example, see this part. See, we are going towards the right. Okay, we are at row number 0, we are going towards the right. Okay, then we will come down, and let's say we are again trying to go up. there is no need to go up, right? Why? How to avoid that? The idea here is, because I can reach any row in the top cell, okay, any cell in the top row with a zero cost, so I should not incur additional cost to reach the top row. So that is the basic idea why we are including this particular conditions, okay. So if you segment the solution, this will again work, okay. This is no harm in this. So this whole value will continue, and since we are appending the values here, okay, we are again updating the cache value here, and that's why if you now you will get to know this condition why it works, okay. See this part. If you go below that, what is happening is we are now trying to go to the adjacent cells of the current cell, okay. For that reason, whenever you reach the last cell, okay, right bottom of cell, you need not try to go to adjacent cells, okay. As simple as that. For that reason, whenever you reach the target, you should not continue further, okay. The idea is you should continue further, you should go to the next loop directly, okay. As simple as that. So at last we are returning cache value of n-1 comma m-1, okay. That is the right bottom of cell. So this solution will work. It's a very good solution. You can try it, but yeah, it will occur around, I guess, 2000 milliseconds time, okay. Yeah, this solution will work, but it will occur time around 2000 milliseconds. Now if you see the case, what is happening here, see, we are caching the things, okay. See this part, we have done a good thing here, that we are caching the value, but we are not utilizing this cache value properly. Why? See, idea here is, if I am able to even reach a particular cell with a zero cost, why at all should I even spend something to reach that cell, okay. So this is so the idea here is, you should first try whatever cells that you can reach with a zero cost. Only then you should try about reaching a cell which is not having a zero cost, okay. As simple as that. Only then you can think about incurring a cost. So the idea here is, the next one that I'm going to show you, this point will become more clear. So just see the solution once, and then we'll go to the next solution, okay. So now I'm going to the next solution. In this solution, the only difference that I'm going to now make is, see this part. Now this is the only additional thing that I'm going to make here, okay. See this part. In the first case, where we are following the direction of the grid, if you see, if the cost till now, remember, this is going to be the cost in which I am going to enter double x double y, right? So if this is zero, okay, if this is zero, that means we are reaching double x double y from x comma y without incurring any cost. In that case, what we have to do, in that case, I'm just going to do append left, okay. In the previous case, just see what I did. In all such cases, I did just append means it will appending from the right, but this time I'm going to append from the left, okay. This will be from up and left, okay. This will be up and right. This also will up and right, okay. Because in both these cases, cost till now is not zero, okay. This case also it is not going to be zero, because here we're anyway adding a plus one. Here we're not adding a plus one, but we got to know that it is not zero, okay. So again, for all those reasons, what we are going to do, if the cost till now is zero, only then do up and left. Why we are doing up and left, and how it is going to helpful, see this part. Because if you see what we are doing, we are always going to pop a value from the left. So the idea is, if you are appending a value towards the left, that will be popped first, okay. So the idea here is, how this will work is, see this part. All the cells which can be reached with a zero cost, okay, which can be reached with a zero cost just by following the directions, they will be visited first, and accordingly their cache values will be updated, okay. Accordingly their cache values will be updated. So how this will help us is that, so the next time when we're trying to visit the cell after incurring a cost, we will not be entering to the circulation because of this condition, okay. Since the cache value is again going to have a zero value there, because this cell can be double x double y can be reached with a zero cost itself, why to incur a cost and reach there, okay. For that reason, it's always beneficial to see what all cells we can visit with a zero cost. For that reason, we are including this particular condition, okay. This will save you around 500 milliseconds in the overall, I'm saying, okay. If you segment this solution, it will be better than the last solution that I showed you, and it will be around 500 milliseconds faster, okay. As simple as that. So now it will make more sense why I'm using pop left here, okay. First thing. And similarly, because I'm using a DQ, in DQ you always have option to do append left, okay. Remember, in a list also, you can without using this function, you can append to the left, that is in the zeroth index, you can append some values, but remember, that will take O of n time, okay. But this will take O of one time. All the appends in the DQ will take O of one time. Similarly, all the pops, okay, whether you're popping from the left or right, is going to take O of one time. So that is the best part about the DQ library. So if you want to use the DQ library, okay, see this part, how you have to use it. You have to just import it from the collections library, okay. As simple as that. Just do that and you are good to go, okay. This was the same solution, okay. The only difference that we made here is that, if the cost is zero, we are appending it towards the left, okay, because we are popping from the left, okay. So the idea here is, we want to first go to all the cells which can be reached with a zero cost, okay. That is the basic idea. That's why we are trying that, okay. Because if we fill the cache values for all of them properly, the idea here is, we will be eliminating multiple circulations. That is, we'll be eliminating multiple traversals that are going to happen because of them, okay. As simple as that. So this was again a very good solution. You can try this also. Next, according to me, the solution that worked with the minimum time in my case is going to be this solution which I'm going to show now, okay. This is going to be slightly different. This is the Dixitras algorithm, okay. Remember, whatever algorithm I'm mentioning you, this is just the base algorithm, but I have always modified the algorithm in order to apply it for this particular case, okay. So if you're seeing a Dixitras algorithm, do not think that, okay, exact algorithm I'm going to implement. I will always modify the things according to my need, okay. So yep, this is not going to be a shortest path algorithm. In this case that I've implemented, this is not going to be a shortest path algorithm. Okay, I'm just taking the ideas from this algorithm and I'm implementing in my solution, right? So you can say it's a modified form of the Dikshita algorithm. Okay, as simple as that. Let me write it here itself because you will get confused. Okay, this is the modified Dikshita algorithm, right? So if you are sure what is Dikshita, the first thing that should come to mind is heap. So first of all, you are importing a heap. So the idea is very simple. See, here what we are doing is whenever we are seeing as zero, okay, see this case, whenever we are seeing as zero, we are appending towards the left because we want that to be, visited first, okay. But only for zero we are doing that, okay. For every other thing we are just appending towards the right. The idea here is whichever value, that is whichever cost is minimal, that should be explored first, okay. That should be our aim. So for that reason, the best way to do that is using a heap, okay. I'm going to use a min heap, okay. If you're not aware what is a min heap, just go and Google it once. Min heap will always give you the minimum possible value present among all the elements in the heap, okay. So see this part again, same thing. I'm capturing the number of rows, number of columns, and all that. I'm filling a cache. Cache is going to be same. It is going to have a float of infinite value initially for all the values. Same thing here, like we did initially. Cache of 0, 0 equal to 0. Then this is going to be a min heap now, okay. So this is not, see, previously we take a dq here. Q is going to be tq here, okay. But here, see, I kept the name as it is, but ideally you should be keeping the name min heap here. Okay, I kept the name q itself because I just modified this code to get this code. But again, you should be, if you want a meaningful name, this should be named as a min heap. Okay, this is the most meaningful name possible. Then I'm pushing my first element inside the heap. So this is how you have to do it. Heap q dot heap push. You have to do the name of the heap and the value to be inserted. Okay, here the things are slightly going to change. See this part. So this, if you see, the first value was x, y, then the cost till now. But here we'll have to change the stuffs here. The first one will be cost till now and the rest of the will be x and y. Okay, why to do that? Because the sorting will happen based on this. Okay, not the sorting, but the idea here is the leftmost value in the heap is going to be something which is going to have the lowest cost. Okay, for that reason cost has to be the first element uh, inside the element. Okay, so this is whole thing is going to be a single element. So all the elements will be compared based on this particular value. Okay, so this has to be the first value in the element. Okay, as simple as that. So this value is going to tell me the cost incurred to reach 0 comma 0. Okay, as simple as that, right? The direction is going to remain the same what we used previously. Okay, then till this question not empty, we have to do that. Do a heap hop. See, the things will change here. See what we're doing here. We have x comma y comma called cost till now. Here we are going to have a different order. Cost till now will come first, then we are having x and y. Okay, so if you have reached the bottom rightmost cell, okay, just continue. This is same as the previous code, right? This part, see, this part is again the same. See, I will tell you where the difference are coming. This part is again the same. Okay, this part is again the same. This part is again the same. Yeah, this also is the same. Okay, most of the things are same. See this part, this is the only where the difference is coming. Okay, so if you see what we are doing, we are just, here if you see what we have done, let me go to the first solution. Yeah, we are doing something like this. Okay, q dot append. In this case what we have to do is we have to do this q dot heap push, the name of the queue and the value to be pushed. Okay, so in all the cases the cost now will be the first element and then x and y. Okay, as simple as that. If this is the case when we are following the directions of the arrows. If you're not following the direction of the arrow, what is going to happen? The cache value will be cost till now plus one. This plus one will now come in the picture. Okay, so you have to append the same here. Okay, in the queue element, right? Heap element, I mean to say. Yeah, so if you see the solution number 3 and the solution number 1, they're almost the same, but only difference is coming here is instead of a queue we are maintaining heap. So since we are maintaining a heap, even during the pop and even during the push you will see the difference in the code. Okay, even during the pop and during the push you will see the difference in the code. But how it works is that whichever else element is having the smallest cost, okay, that will be taken first, that will be popped first. So we'll be exploring all the adjacent values of that cell to which we reach with the minimum cost. Okay, that is going to the basic idea here. Okay, since we are also caching the values, see this part, since we are also caching the values, this will have that if we are even the code is even trying to reach a cell which is already visited with a higher cost, that will not be allowed. Okay, that exploration will not happen. Okay, because this condition will be violated there. Okay, so only if the cost to visit a cell is lower than the previously visited cost, only then we will explore it again. Okay, otherwise we will not do that. So yep, that is how it is going to work. And this part is same. We are returning the cache value of n minus 1 comma n minus 1. Okay. Yep. So remember, friends, one more thing that I want to tell you that, see, since we are following the heap, okay, heap will always give you the minimum cost till now. So the idea here is once you reach x minus one and m minus one, you can basically break also. Okay, I'm telling you this from my experience. You can even break the code and return maybe the value of cost till now. You can try that. That should also work because that is going to the minimum value that you can reach. Okay, so you can even this will be even optimal solution. Okay, what you can do is here you can write return cost till now. Okay, I will try that and I will let you know if it works, but according to me this should work. Okay, because we are trying to reach the right bottom of cell with the minimum cost till now. Okay, so because the sorting will happen in such a way that we are exploring the minimum cost till now first. So whenever we reach this particular cell first, with the minimum value in this, then that should be the answer. So you can even break this and ignore further iterations. So Evan, that was all for this particular video. And yep, this was a very nice question. Do not worry if it is marked as a hard question. This was a very nice question. Yeah, you will take some time to understand the ideas, but maybe you can look at the hints. Okay, you can look at the hints given here and then try to formulate approach and then try to solve it. Okay, that is what I will say you, because see, even in a interview setup like a face-to-face interview, you can ask for some hints. Okay, like see, because the whole question is going to revolve around this. Okay, if these are slightly smaller, you can think about graph algorithms. Okay, you can think about DP algorithms. But if this is very very high, then it's always better to get some hints. Okay, like what exactly they are trying to aim here. Okay, only then it's better to think of a solution, otherwise it will be rework for you. So often that was all for this video. I showed you three solutions and each one solution is better than the other, and I also give you idea for the fourth solution that you can break. Basically here you can return the value of costilna from here. That is, you are returning the answer from this, okay, this condition. This will help you save some of the iterations. Okay, as simple as that. So often that was all for this video. If you like my efforts, please do subscribe to the channel. This really takes a lot of motivation, especially like on a weekends like this. It really takes a lot of motivation to do design this kind of solutions for you. Okay, I do not copy from anywhere. Like these are purely designed by me only. I do not I just take ideas from other places, but the code that we're seeing is exactly my code. I do not copy from anywhere. I believe that, see, the purpose of making this YouTube channel, purpose of making these videos is that you should grow. At the same time, I also get opportunity to grow. Okay, that my aim is to get you to all the solutions. For that, I also do a lot of homework. My aim is that in order to help you, I am also helping myself. Okay, that is the basic motto with which I started this channel. That I also need a reason to code every day, to provide, to seek optimal solutions, to get you optimal solutions. Okay, so if you like my efforts, please do subscribe to the channel. This really gets a lot of motivation to continue further. And yeah, see you tomorrow. Thanks a lot. Please subscribe.